All right, let's take a look at the quicker questions for Chapter 5, Regression. The regression line for body fat index, BFI, as a function of tricep thickness in millimeters is BFI equals 14.59 plus 0.74 times tricep. In this equation, BFI is the blank variable and triceps is the blank variable. So triceps is the input and BFI is the output. So the output is the response variable and input is explanatory, so B. The regression line for body fat index is, as we've seen before, what is the average amount by which BFI changes when tricep thickness increases by 1 millimeter? It changes by the slope, 0.74. Look at the following scatter plot. What would be the correct interpretation of the slope? So our slope is 1.1. So A or B, and it's changing per 1 unit of the other, so A. So 1.1 is our slope, changing by 1 milligram of our X input. Still our regression line for body fat index. Predict the body fat index for individuals with tricep thickness of 35 millimeters. So 35 millimeters times 0.74 plus 14.59. Answer C. The regression line is still the same. What is 14.59 in this equation? The 14.59 is the intercept, and the intercept is where the X variable is 0. So all of the above. Look at the following least squares regression line. If a person increased his or her or their weight by 10 pounds, how much in inches would one expect to see their waist girth increase? So if a person's weight increased by 10 pounds, we would multiply 0.1332 by 10, getting us 1.332, and then we would add to it the 9.9994. But we aren't finding the y value, just the change. So look at the following least squares regression line. If a person increased their weight by 10 pounds, how much in inches would one expect to see their girth increase? So just the increase itself is the 10 times 0.1332, so B. Given the regression line, MPG equals 48.74 minus 0.0082 times the weight of the vehicle, I'm assuming. Calculate the predicted miles per gallon value when the weight is 3,000 pounds. So 3,000 times 0.0082, and then we'll subtract that from 48.74, which gets us 24.14. Given the regression line minus 10 plus 2.7x, where y is the motor vehicle fatalities in 100,000 residents, per 100,000 residents, and X is the percent of the population for ages 18 to 24. Which of the following correctly predicts the number of motor vehicle fatalities in a state where 1/4 of the population is aged 18 to 24? So we would put 25 the 1/4, 25% into the x value, multiply that onto the 2.7, and add that to -10. So choice B. Given the regression line, y equals -10 plus 2.7x, the same as we saw before. For every one increase in x, the model predicts a blank change in the predicted value of y. So for every 1 unit in x, you're going to change by the slope in units of y. So part C. Look at the following least squares regression line. Compare the squared errors from 2 points, A and B. Compare them. So one choice is there's not enough info. Another is point A's squared error would be greater than point B's. I think greater because point A has a farther distance. So choice A. Least squares regression line. What would happen to the least squares regression line if we remove the following states, Utah and North Dakota? Well, it would change the line, and the line would go up a little, so it would increase and become more positive. Our line would increase in slope and become more positive. Which of the following makes no distinction between explanatory and response variables? That's the correlation. So it didn't matter in correlation which variable we chose to be which thing. It does matter in the regression. If y is the response variable and x is the explanatory variable, what does the regression line allow you to do that correlation does not? Calculate the predicted value of y given a value of x, the last choice. Look at the following scatter plot. What could we say about the relationship between r and the slope of the regression line? R and the slope are both positive. So B is our slope and R is our correlation. So slope is positive and R is positive. Which of the following measures the direction and strength of the linear relationship between x and y? The direction and strength is correlation. That's our R variable, right? And R contributes to slope. Which of the following is used for prediction? That would be the regression. Which of the following best describes the relationship between correlation and slope of the regression line? The sign of the correlation between x and y is the same as the sign of the slope of the regression line, modeling the relationship between x and y. The sign of the correlation, r, is the same as the sign of the slope, b. In a regression setting where y is your response and x is an explanatory variable, the square of the correlation, or r squared, is, the fraction of the variations in the value of y that is explained by the least squares regression of y on x, the very first choice. For a set of data, r equals -0.8. One of the following statements is correct. Which is it? So a change of 1 standard deviation in x corresponds to a decrease in 0.8 standard deviations in y, or 80% of the variation in y is explained by the regression of y on x. So 80%. Which of the following best indicates the usefulness of a regression line for prediction? Correlation, square root of the correlation, or the R squared? R squared tells us the percent, let's go back to the last one, the percent of the variability in Y, so R squared. The line relating BFI to tricep thickness that we were looking at, and the line relating the BFI to neck thickness is similarly written. BFI equals 17.34 plus 0.35 times the neck thickness. Which regression line is more useful for prediction of BFI? So we need R to be able to say that. So there's not enough information here to say. The squared correlation R squared of BFI and tricep thickness is 0.72. And the squared correlation R squared of the BFI and neck thickness is 0.18. Which regression line is more useful for prediction of BFI now? Right now we can say that the one with the 0.72 is better than the 0.18 because 72% of the variation is accounted for in the first equation. So BFI versus tricep thickness. What percent of variation in the sister's height can be explained by the heights of the brothers? So R is 0.558. If we square 0.558, we get 31.14%. So 31% of a sister's height could be explained by the brother's height. Which point has a larger residual? Point A is farther away from the blue line than point B. Residuals. Oh, just which one is the residual? It's the observed value minus the predicted value. The residual plot is used to examine how well a regression line fits the data. What does the residual plot indicate? The relationship between X and Y cannot be modeled with a straight line because this doesn't look scattered. This looks like it has a U shape. So this residual plot tells us our data is not modeled by a linear equation. The residual plot should be scattered and not forming any type of shape. The least squares regression line always passes through which point? It always passes through the point of averages, the X bar and the Y bar. The following graph indicates the presence of an influential outlier. It's that one on the end there. If we took that out, our line would certainly shift up and be more in those dots. If Kansas were removed, the correlation would increase, decrease, or impossible to say. If Kansas were removed, the correlation would decrease because R would decrease. And R squared, oh, R is the correlation. True or false? Kansas is an influential outlier. Since this least squares line would move significantly if we removed Kansas, then yes, it is. In 1999, a 1999 observational study reported in the prestigious journal Nature found a positive correlation between ambient lighting in a baby's room and degree of myopia later in life. What should you do about this information? Accept it without question, Accept it tentatively, away your baby's nightlight to prevent myopia, or wait until an experiment is done. They won't do an experiment to try to give someone myopia, right? So you just accept it tentatively. The myopia study referred on the previous slides was later criticized. A second study showed no relationship. One of the following was suggested as a lurking variable in the first study. Which was it? Think carefully about which variable might have influenced the relationship. Who would have tended to both use nightlights and pass on myopia to their children? Parents with the disease themselves can't see at night and have nightlights on so they can see their own children. The graph shows the least squares regression line for predicting diamond price from diamond size for diamonds that are 0.35 carat or less. Using the relationship to predict the price of diamonds that is 1 carat is an example of extrapolation, because that's like 3 times larger than the largest size diamond we have here. Thank you.